Good afternoon, everyone. This is Mr. Peters. Again, this is your Algebra 2 review for your exam tomorrow, as promised. Just please remember that you have your Delta Math due tomorrow. And again, if there are any questions, please email me, or Mr. Palacios, you can email me at dpeters@bxcsm.org. Okay, all right, first question. It says use graphs 1 and 2 below to write a description of what it means for a function to be positive or negative, okay? So the descriptions below actually talk about the graph being positive or negative. And the key to knowing whether it's positive or negative is looking at the x-axis. So for this first one, it says the graph is negative over the intervals 2, 4. So if I look at the intervals 2, 4, from 2 to 4, what I'll recognize is that that is negative. So what you're really looking at is the x-axis, okay? Anything below the x-axis is negative. So in this event, 2, 4 is below the x-axis, it is negative. Anything above the x-axis is positive. So in this event, this part and this part is above the x-axis, so that's why that is deemed positive. So in this interval is positive from negative infinity to 2, and it's also positive from 4 to infinity. Okay, so if they ask you a question tomorrow and they talk about positive or negative, your key is looking at the x-axis. Okay. So again, below it's negative, above positive. Okay. Okay. So, looking back at that question again, the second part. It says the graph is negative over the interval 0, 1. So this is 0 to 1, and we look, the graph is below the x-axis. And because it's below the x-axis, it is negative. Okay, same thing here. Once it's below the x-axis, again, it is negative. Okay? All right. So, talking about continuation again. And if you want, the best thing for you to do is just kind of trace out for yourself. So, okay, that's below the x-axis, so that must be negative. This is also below the x-axis, this must be negative, and vice versa. You know, everything over here is positive. Okay. All right. Moving on. So, for question 59, we give you a brief description about functions being either even or odd. Okay? So, talking about this question right here, if the function reflects over the origin, and the origin is here, right to the middle, it is an odd function. So kind of look at it from this perspective. If I were to take this point and move it over here through the middle, it would go right here. Okay, so that is considered an odd function when it is reflecting over the origin. Okay, now even functions. Even functions is when now you're using the y-axis. Okay. So when it reflects directly over this line, which is the y-axis, that's when you know it's an even function. So, for example, if I'm here and I reflect it over this line, it is right here. Okay, so the two reflections you're looking at is either reflection over the y-axis, which is even, or reflection over the origin, which makes it odd. Okay, so in question 59, if I scroll down, it's either going to be even, odd, or neither. So let's take a look. This one, I'm going to draw my first step for this question, I'm going to draw a line. I'm going to say, does that reflect over that line? I'm looking at it, it does not reflect, so it's not an even function. Okay. Now I'm going to look at the origin. Does it reflect over the origin? Origin is right in the middle. It doesn't, so in this case, this is neither. Okay. I'm going to look at the second one. Again, I'm going to follow my same rule. I'm just going to draw a line down. Okay, when I draw a line down, it looks like it reflects over the y-axis. So again, if it reflects over the y-axis, it is even. Okay, same thing here. I'm going to draw a line down. I'm looking. That's not a reflection, because if this is here, then this point would have to be here. So this is not an even function because it does not reflect over the y-axis. And now I'm going to go to my origin, which is 0, 0. And I look, if this point is here, then the reflection would have to be here. So this is also neither. Okay, so we have two neither so far. Let's take a look at this one now. So I'm going to draw my line down. This doesn't reflect on this side, so it's not an even function. So now I'm going to look at my origin. When I look at my origin, it seems to reflect over the origin, meaning that it's going here, and then when I come across, and it's kind of like you draw a line over, it's right there. It's kind of like when I draw a line over, it's like a little connected dots, it kind of connects. So in this case, this is an odd function. Okay. This last function a little bit trickier, because we don't have a graph. So what you can do, especially if you have your calculator, you're going to open up your calculator. Okay? You can actually create this function. So on the screen, I have my calculator. I'm going to press stat. I'm going to press edit. And I'm going to type these numbers in. So I'm going to put -2. I'm going to put -1. I'm going to put 0. I'm going to put 1. And I'm also going to put 2. I'm going to go to the other side. I'm going to put -8. I'm going to put -1. I'm going to put 0. I'm going to put 1. And I'm also going to put 8. Okay? But let's pretend for a second that I don't have a calculator, which some of you guys don't have. How would I then be able to graph this? It's simple. You can use graph paper. So I'm going to go to a clean page for a second. I'm going to pull out some graph paper. And I'm going to graph those points, and I'm going to check and see whether those points match. So my first point was -2, 8. So I'm going to go on my graph to -2, and I'm going to go up to 8. I'm going to plot my first point. And I'm going to come back just to look at the numbers. My next one is -1, 1. I'm going to go to -1, 1. Okay, my next one is 0, 0. Then I believe it's 1, 1, and 2, 8. So what I just simply did was I pulled out a graph and plotted it. Now I'm going to do my same steps. I'm going to draw my line through the y-axis. And what I realize is they're a direct match. So this is also a even function. So again, just a quick reminder, if it's even, it reflects over the y-axis. If it's odd, it reflects over the origin. Okay? All right. Moving along. Average rate of change. Average rate of change you've just talked about, you've discussed it in algebra, okay? So question 60 reads, a continuous function is defined in the table below. Find the average rate of change over the intervals 2, 6. So, in this situation, it gives me the intervals, what I'm looking for, okay? So in this case, I'm looking at 2, and I'm looking at 6, okay? F of x, you're going to see a lot of f of x. F of x is also y, okay? So what you're going to do in this case, you're going to use your two coordinates. So you're going to have 2, 160, and your other coordinate is going to be 6, 80, okay? From there, you're going to make your x1, y1, and you're going to make your x2 and y2, okay? All right, so as we talked about in class today, we had a formula for this. Please remember this formula. It's something we talked about all throughout high school. y2 minus y1 over x2 minus x1. From there, I'm going to plug my numbers in. So when I scroll back up, I know that y2 was 80. I know my y1 was 160. Okay? I'm going to scroll back down. My x2 was 6, and my y2 was 2. So now I have 180 minus, 80 minus 160, which is -80. I have 6 minus 2, which is 4. I now divide, I'm going to get -20. So my rate of change is, in this case, -20. Why? Because I'm going down. I'm going down 20 each time. So from here to here, I'm going down, actually from here to here, I'm going down 40. But because it's missing a 1, and this is missing a 3, and missing a 5, and a 7, and a 9, what I've determined is, based on my formula, the average rate of change is -20. Okay? And what this function is doing is just keep going down. Okay? Okay. We struggle a little bit with this with extreme values. So we have 4 extreme values. We have absolute minimum, absolute maximum, relative minimum, and relative maximum. So we gave you in the packet some examples to tell you which is which, okay? So in this case, we talked about the first one, which is the relative minimum as at negative 2.5. So I'm going to look for negative 2.5, excuse me, relative maximum, excuse my language, relative maximum. I'm going to go 2.5, and what am I going to realize? I'm going to realize that my point is there. It's sloping up, and it's the lowest slope up, okay? So the relative maximum is that point, then the absolute maximum has to be the same slope went up, but a little bit higher. So if this is the highest point, it's absolute. The second highest point in this case will be relative, okay? So in the example, the absolute maximum is 6. So we're right here with 6, okay? So that is your highest point, okay? In this case, your relative minimum is negative 4. Why? Because it's your second lowest point. Now, something is missing from here. What's missing from here is the absolute minimum. It's missing because it's not the lowest point. So if this is our second lowest point, then my lowest point has to be here. And that is your absolute. And in this case, it's about 2 or 2.5. So just remember, when we're talking about relative and absolute, relative is kind of like the second lowest point, and absolute is the lowest point, or in this case, relative maximum is the second highest point, and absolute is the highest point, okay? Okay. All right. We didn't spend too much time on this. We kind of talked about this a little bit in the last question about how to find systems of equation. So the key to this equation, and again, please remember this because I'm not going to go over the whole question, but the key to this question is making sure that the numbers are the same. What do I mean by that? So what I'm saying to you guys is when you're answering this question tomorrow, make sure one of these numbers are the same. So in this case, since there's nothing here, we can add a 4 here. But whatever you do to 1, you have to do to everything. Okay? So now you make this look like 4. Or you can also, I'll erase this for a second. Instead of the 4, what you also could do is you could make this 3 into a 9. How do you do that? Well, let's think about it. How do I turn a 3 into a 9? Okay, after you're done thinking, you're going to realize you turn a 3 into a 9 by multiplying by 3. Okay. If we multiply this question by 3, then what's going to happen is this will become 3x, this will become negative 9y, and this will become negative 18. And now you have this saying 9 and this saying negative 9. Okay? Now let's understand elimination. So we're going to just cross this out for 1 second because you rewrote this into this. If we're doing elimination and one is positive and one is negative, we are adding. Okay? That is the operation we're doing. We're going to add the entire equation. If that was positive and this is also positive, then you would be subtracting. Okay? So just remember, when the numbers are the same, you are subtracting. When the numbers are different, when one is positive and one is negative, you are adding. So let's go back to the original question for a second, and let's just make sure we understand this concept. So this is a minus. So because that's minus and positive, we're going to add the whole thing. Negative 4 plus 3 is negative 1x. The 9s cancel out. And now I'm going to get 9 plus negative 18, which is going to give me negative 9. When I cross out by negative 1, x is going to give me 9. And it's simple. For y, you pick one of the original equations and resolve back for y. Okay? Again, we talked about this. You should know how to do this. Just remember, one of the coefficients, and the coefficient is a number for the variable, has to be the same. Okay. Questions 63, 64, and 65. We just talked about average rate of change. Okay, so I'm not going to talk about it again, but just remember, if my interval is negative 3 and 1, I'm going to look for negative 3. So this is 1, 2, 3, negative 3. and I'm going to look for 1. I'm going to put the 2 points, and I'm going to find the average rate of change, okay? Positive or negative, we also talked about this. So positive or negative, I'm going to draw a line through the x-axis again. Anything above is positive, anything below is negative. Determining something whether it's even or odd, so remember, even or odd, even crosses which axis? The y-axis. So I'm going to make sure it reflects. So this does not reflect over here, so it's not even. Odd. Odd is this part right here. Now I'll make it a different color so we're clear. It's the origin. So this, does this reflect over here? Maybe. Does this reflect over here? Maybe. So this may be an odd integer. It's something you really have to investigate. Neither means it's neither, okay? So again, 63 we talked about, positive or negative. 64, average rate of change, find the 2 points. Determine whether the function is even or odd. Even, again, is the y. Odd is the origin, and neither is neither. Okay. Question 66, 67, 68. Approximate the coordinates of all extreme values of the function at right. Categorize each extreme value as either a relative maximum or relative minimum. This function does not have an absolute maximum or minimum. Why? Because what's missing from here are arrows. So what this implies is this thing has arrows, okay? So now I'm going to look. Maximum is going to look something like this. Minimum is going to look something like this. I'm going to look. What's the highest point here? Oh, it seems it's right here. Okay, so that is going to be your relative maximum. Relative minimum, kind of the same thing. A u, the lowest point of the u, that is going to be my relative minimum, okay? And in this case, I'm just going to find the points, okay? Interval notation to approximate all intervals where the function is negative. Again, we talked about negative. Negative starts below. It seems like because this is going, I'm going to have to put my negative infinity. It goes right to about close to 4, it looks like. So maybe, let's say, negative 3.8 maybe, or whatever that number is. It looks a little low on my screen. Okay, I'm looking again down, and that's a 3, guys. Sorry, I'm writing with my finger, so if it looks a little messed up, I'm sorry. I'm looking here. It also seems to be going down. If that's a 1 and the 2, negative 2 is there, so maybe about negative 1.2. We'll try to make it a little bit clear tomorrow. It's still going down, still going down, still going down. It's going right about 1. Okay? So those are my negatives. My negatives from here to here, and then my negatives from here to here. Okay? And we talked about why this function does not have an absolute maximum minimum, because it keeps going. So there's no absolute value. It's going to keep going. Okay? Okay. If h of x is negative x squared plus 4x minus 1, what is the average rate of change of h of x over the intervals 2, 6? So again, we discussed this. H of x in your calculator is going to equal y. So again, what you could do is break out your calculator, turn it on, press y equals, okay, press y equals, and what I could do, a lot of functions on here, I could type the function in. So I'm going to go to y1. And I'm going to type the function in. So the function is negative, and the negative button's here, negative x squared plus 4x minus 1. And what I'm going to do is I'm going to look for the table. So I'm going to press second, and I'm going to press graph, which above graph you see the word table. And now it gives me a table. So now I can look at the intervals 2 and 6. So I'm going to scroll down, and I'll make it a little bit bigger so you can see. I'm going to go to 2. So my first point is 2, 3. I'm going to continue looking at my graph. I'm going to go to 6. And now I'm going to have 6, negative 13. If you do not have a graph calculator tomorrow, you can do it the old-fashioned way, which is using just doing the work. So if x is 6, and I'll do the first one so you can see it. If x is 2, then what I'm going to do is I'm going to replace every x with 2. So it's going to be h2 equals negative parentheses 2 squared. So again, all I did was take the x and put 2 plus 4. Again, I'm going to take the x and put 2 minus 1. Okay? 2 squared is 4, and then you have your negative on the outside, plus, that's 8, minus 1. Negative 4 plus 8 is 4. 4 minus 1 is 3. So you get the same answer either way. Okay? Once you're done plugging it in, use your formula. So y2 minus y1 over x2 minus x1. Okay? And if you don't have a calculator tomorrow, you could use the same thing. So in the second event, you're going to replace the x with 6, and you're going to get negative 13. Okay? All right. On graph paper, sketch the function that is positive over the intervals negative 1, 3, and 8, 10. So, positive. What does positive mean? Positive means over the x-axis again. So anything positive, okay? So if 3 is here, right? I know that's my turning point. So I know that it's going to go down at 3 and it stops here. So I'm going to start at negative 1. And I'm just going to go positive. I can go like this. But I know it's going to go down at 3. Same thing at 8. I know it goes from negative to positive. So I'm going to put another point here. So I know that it has to curve back around again. So what I'm going to do, I made my 2 points, and I'm just going to curve it down. And then it stops at 10. So I may go here and stop it here. Okay? And please make sure you pay attention and understand, okay? And again, this is an open circle, okay? Because it's a parentheses. Bracket means closed circle. Parentheses means open circle, okay? So again, that's the tips to this question. Just look at the points. I know it turns at 3, and I know it turns at 8, and those are the 2 points I made, and I just made sure anything positive was above the x, anything negative was below the x. Okay. Even, odd, neither. We talked about this. You should be able to do this now. Draw the line through. If it's even, it's going to reflect over the 2. If it's odd, it's going to reflect across the 0. And if it does neither of that, it is just simply neither. Okay? Okay. Sketch a function over the intervals, negative 5, 5. That means follow criteria. So, absolute minimum, 2. So I know my lowest point has to be at 2. Relative minimum, negative 5. So I know that if this is my lowest point, then negative 5 has to be my second lowest point. So if I'm going to sketch my function, that has to be the lowest point. Okay. Relative maximum at 5. So 5 might be here. Absolute maximum, negative 1. So I know negative 1 has to be higher than 5, so I'm going to make it here. So what am I going to do? It's just simple. I might start here and just go like this. Shoop. So 2 is absolute, so that has to be lower. And 5 is relative. Boom. So I just made 5 points. This is negative. Oops, wrong spot. Put at negative 3, should have been at negative 1. So let me make that correction. So it should have been a negative 1 here. So I'm just going to make my correction. I'm going to draw this one here. Okay. So now let's try this again. Negative 5. Okay. That's the lower. Then 2 is absolute. So if that's lower than that, I'm good there. Let's try this one. Absolute, negative 1. That is higher than this one, which is 5. Okay. Perfect. Questions? Seems pretty straightforward. Okay. State an interval where it's both increasing and negative. So increasing means it's going up. Negative means it's below x-axis. So I'm looking at below the x-axis first, and which one of these are going up? Okay, I'm just going to sketch it in. So this seems to be going up. This seems to be going up. And that's it, that's going down. So I have my two intervals. So I have my negative infinity to a, and I have my b to c. Okay. State of interval was both decreasing, so it's going down and positive. So positive simply means positive has to be above. So I'm looking above. And where is it decreasing? So I'm going to look, that's going up, this is going down, that's my decreasing, that's going up, that's going down. So those are my intervals. Okay? Again, we talked about relative absolute minimum maximum, so you should be able to answer that now. Graph the function f of x using decimal, so your graphing calculator. So again, you have to use your graphing calculator for this one. Once you use your graphing calculator to determine, so again, you're going to go press on. You're going to plug your function in by pressing y equals. Once you plug it in, you should be able to put the graph, and then once you make your graph, so let's say I'm going to plug this in, so this is negative 1 over 2 x squared plus, I'm going to delete everything else, so I'm going to press delete, 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 plus 5. I'm going to press second and graph. I'm going to have my table. Okay. After I have my table, I'm going to just press graph, and now I'm going to have my graph. Looking at that graph, I now know, because it seems to cross through this axis, it is a even function. Okay. Average rate of change, again, we talked about this. Remember, your two functions are -2 and 2. So when I pull back up my calculator, I'm looking at, I'm going to press second table, I'm looking at -2. So that's -2, 3, and 2, which is 2, 3. And I believe we did this one in class today, and we realized there was no change, so it was 0. Okay? Take your time. Good luck. Please make sure you guys are studying, and please make sure you do your Delta math. And again, if there are any questions, you can email me at this email address. Okay? And also, you can send me any reviews. So if you felt like this video was good, suitable, wasn't good, you want any more feedback, please let me know, okay? Guys, study tonight. Good luck. See you in class tomorrow. Bye.